Geomasters. Today's lesson is on why mid-latitude cyclones move like minibus taxis on the N1, mostly eastward, but sometimes taking wild detours. Let's break down the South Atlantic High and South Indian High's tug-of-war over these storms. But before we get into it, note that mid-latitude cyclones do not occur in isolation. They form in groups in the west wind belt and move eastwards. Sometimes as many as 4 or 5 pass through a certain area in quick succession and are visible on a synoptic weather map. We call these cyclone families. Ready? Let's roll. At this stage, we already know that mid-latitude cyclones generally cruise west to east, easterly, like a Cape Town to Durban road trip. Why? They're steered by the prevailing westerly winds in the mid-latitudes. But sometimes, the South Atlantic High and South Indian High hijack the cyclone's GPS, memorize easterly movement as their default setting. The South Atlantic High is like a fuel pump for cold fronts. Its anti-clockwise winds, spinning like a backwards clock, pump cold, dry air behind the cold front, turbocharging it. Imagine the South Atlantic High as a Bry master fanning flames. More air equals stronger cold front. Remember the 2022 Eastern Cape floods? South Atlantic High was on steroids, feeding that cold front like a Pappenblaze feast. Let's shift to the Indian Ocean. When the South Indian High parks itself in the cyclone's path, it's like a roadblock forcing a detour. The South Indian High's counterclockwise winds shove the cyclone further south, like a taxi dodging traffic, then eastward into the Indian Ocean. There, it fizzles out or dissipates like a load-shedding generator. This is called a blocking high. South Indian High literally blocks the cyclone's usual route. Let's map this detour. 1. Cyclone approaches South Africa. 2nd. South Indian High blocks it, forced south. 3. Cyclone turns towards east, Indian Ocean. 4. Dissipates like a WhatsApp group after exams. Let's rewind back to 2020 when storm drenched the Eastern Cape. South Indian High blocked it south, then it vanished over the ocean. Take note of backing versus veering winds. Backing equals winds shift counterclockwise, left, to cold fronts. Veering equals winds shift clockwise, right to warm fronts. Backing winds bring the cold, veering winds warm the bold. Test your mid-latitude cyclone skills. 1. Describe the area of formation of mid-latitude cyclones. 2. Can you identify and explain the various stages of development? 3. Name the general direction of movement and provide reason for it. 4th. Distinguish between the weather conditions caused by a cold, warm, and occluded front. 5. Draw a labeled cross-section of a cold, warm, and occlusion front. 6. Discuss at least 4 impacts of the cold front. And lastly, suggest strategies to reduce the impact. If you aced these questions, congratulations! You have earned yourself a badge as the master of mid-latitude cyclones. Wrapped up mid-latitudes. Next up, we switch our focus to tropical cyclones, where storms swap cold fronts for beach vibes. Step on that subscribe button. Need some clarity? Let us know in the comments. See you in the next lesson, Geomasters.